I'm John Pendry and I'm going to give the Kavli lecture on nanoscience today. I'm going to talk about the way nano objects interact with light. And there's a problem there because light normally interacts with things of its own wavelength, which is about a micron, which is 1,000 times bigger than a nano. So we have ways of solving that problem, but they involve some very fine-scale engineering, and I'm going to address those problems today. Snell's law tells you how rays of light refract around in an ordinary lens in your camera. When you get down to the nanoscale, you're actually looking inside the wavelength, and rays don't mean anything anymore. But there's something that still has a meaning, and that's the electric and magnetic fields that constitute light. And transformation optics is about how you transform those by using different materials to push the fields this way and that and control them just as you please. If you can concentrate light very much, it becomes very intense. So ordinary light doesn't talk to light. Photons ignore one another usually, but if you cram them into a very small volume, a nano volume, then you can persuade them to talk to another. So you can use light to switch light and that sort of thing. You can also make very, very tiny lasers, which might be very efficient and useful if you want light on a chip, for example. And my colleague at Imperial College London, Rupert Oulton, actually does make nano lasers, and I'll be talking a little bit about that as well. Materials is a very interdisciplinary subject, and I've just mentioned that if you want to control light, you've got to use a material, and we're quite desperate for new materials in optics. Of course, a lot of things which we really would like to do, and we don't have the materials to do them. So if we can enthuse some of the materials specialists to help us with our problems, then that will be a good consequence of my talk.